transformations, so kind of a cool word. So let's see. So there are 4 transformations. So I'm going to tell you everything you need to know about each 4, and then we're going to move on to exam questions, just because might as well practice with some exam questions. So there are 4. 1, 2, 3, 4. And I remember them as true spelt incorrectly. So there's no other word I can make those into. If you think of one, write it down below. So the T in transformations stands for translation. Okay, so let's go over what a translation is. So if I have a graph, so these all happen on the XY axes like this. A translation would be something like if I have this shape here and then I move it, maybe it comes down here, pretending they look the same. So basically what's happened is I've shuffled this way, then I've shuffled this way. So the shape hasn't rotated, the orientation is exactly the same, I've just moved it kind of like a crab. It's just on a shuffle like a crab. So translation is a shuffle, and the way you write them down is you write it, so you'd be translated, and then you write it like a column vector. So let's say, for example, this one went, I obviously haven't put a scale on this, but let's say it went 5 that way and 5 down. You would do 5 for the x, so positive 5, and then minus 5 for the y. So that is how you would write a translation, and this is what they are. They're just kind of shuffles, or like, they kind of just crab around. So what about the next one? So R can stand for rotation and also reflection. So we've all looked at our reflection in a mirror and we've all kind of heard of the word rotation. So let's start with rotation. Okay, so if I rotate something, so in rotation, I need to give 3 pieces of information. I need an angle, I need to write down the direction, and I need to write down the centre in which it's rotating around. So that's essential. So in an exam question, they might say write down the transformation here, and it might be a rotation. So 3 things you need to write down. A, D, C. So instead of A, B, C, it's A, D, C. Angle, direction, centre. Clockwise or anti-clockwise. So 2 options there. Angle, for example, could be like 90 degrees, 180, whatever. And centre is a point. So normally, quite often, it's around the origin. Let's have a look at what that would look like on the axes. So let's say I have... Okay, so very roughly here, this is what a rotation looks like. So maybe I started with this shape, shape A to B, and the transformation here is a rotation, and we need to do this checklist. So the angle would be 180 degrees in this example. The direction would be clockwise, but you could also put anti-clockwise. And the centre, centre it's rotating round would be the origin, 0, 0. So you can use a bit of paper to do this. I've kind of got a really rubbishy scrap here. But for example, you could get, also this is kind of for baking, not really for rotating, but you could write this here. So here's my shape, copy over it. You could put your point on the centre, then you would go the direction, so let's say clockwise this way. So let's go 90 degrees would be there, and 180 degrees you would end up there. So you can always use a bit of paper to help you. Okay, let's move on to reflection. So for reflection, what you need to write down is an equation of a line. So basically, a reflection is like a mirror. So if we look at it on here, let's say I did the same shape, and let's say, basically, let's say this is you, and this is your reflection. You're kind of asking, where's my mirror? So the mirror in this case would be here, which is on the x-axis. So your equation of the line, you could just write, for this example, would be reflection in the x-axis. Or, so the x-axis is also y equals 0. So the line y equals 0. So that's the equation of a line you would give, so that's the only bit of information you need to give for reflection, and there's an example of a reflection. And our final one is enlargement, which is a bit misleading because it can also shrink. But it's called enlargement, so we'll just go with that. So there are 2 things you need to write down for enlargement, and that is scale factor so like how much it's getting bigger or smaller by, and the centre, so a bit like the centre of rotation, you need the centre of enlargement, so at what point is it kind of enlarging from. Okay, so this is a rough example of enlargement. So I've gone from A, this shape here, and I've enlarged it to get B. So basically what I've done, I need the scale factor of enlargement, so how much bigger has it got? So let's say this is 1, this is going to be 4, so we could say the scale factor in this case would be 4, and the centre, so at what point, so this is 1 away, and this is 1, 2, 3, 4. I'm going to get this 4 away. So our centre is, if you did a projection like this, you should get each point like this, going from that centre point, so my centre here was ideally 0, 0. Okay, so this is our first exam question, and I felt like this topic actually required some accuracy, so we've got some help with this axes here. So, what it's telling us to do, reflect triangle A in the line x equals 4. So as we just found out, all you need for reflection is the equation of the line in which you're reflecting in. So it's kind of saying this is the location of the mirror. So let's find the line x equals 4. So we know that x equals 4 here. So x equals 4 all along this line here. All these values, x is equal to 4. So that is kind of where we've put the mirror. So let's say we've put a mirror there. You can sometimes use a little mirror. What would we see? So if we think about it, it's going to be an opposite, or like looking in water. So it's going to be the opposite. So it's 1 away from the mirror, so it's going to be 1 away from the mirror. Okay, this one is 1, 2, 3 away from the mirror, so it's going to be 1, 2, 3 away from the mirror there. Now we can kind of see we can join those points up, and we're going to have the triangle. So that is the reflection. Okay, so this question, P is drawn on a grid. P is reflected in the line x equals -1 and then reflected in the line y equals 1 to give the triangle Q. Describe fully the single transformation from P to Q. So here it's written it down in 2 transformations, and I want you to give it down in 1. So the first one is x equals -1. So it's reflected in this line. So we're going to put our mirror, this is x equals -1, and this is the line x equals -1. So we're going to pretend our mirror is there, and the way I'm going to reflect. So what would he see in the mirror? This triangle looking at himself. So the way I do this is I get the corners, I'm going to plot those. So that is 2 away, so that is 2 away. 2 away from this line, so 1, 2. This one is 1, 2 away, so we know 1, 2 away. And then this one is 1, 2, 3, 4 away. 1, 2, 3, 4 away. And now you can see my points of the triangle, so now I can just attach those, and that's where it would be. So that's step 1. Then it says it's reflected in the line y equals 1 to give the triangle Q. So one more step. So where is the line y equals 1? So we go to y equals 1 here. So that's going to be this line, because along this line y is always equal to 1. Okay, let's reflect again. So now the mirror is there. So we have, it's 1 away from here, so the corner is going to be there. 1 away there, so the corner is going to be there. This one is 1, 2, 3, 4, 5 away from the line. So we go 1, 2, 3, 4, 5 away from the line. So there are our corners, and now we can just attach them all up. And then that is now triangle Q. So that's the transformation, and it says describe fully the single transformation from P to Q. So how can I get from P to Q in one transformation? So we have 4 options. We can go T, R, R, E. Tree spelled incorrectly. Translation, so is it like the crab shuffle? No, it's not, because it's changed the orientation, so there's no way you can shuffle that and make it go upside down. Reflection. So we could have a mirror on an angle, but doesn't look very likely. Enlargement, it hasn't really changed the scale factor at all. It hasn't got bigger or smaller. So it's going to have to be rotation. So, okay, we've established its rotation. Now, for rotation, there are 3 things we need to do. That is angle, direction, and the centre. So we're going to have to find these 3 points. So, what I really find helps with a rotation problem is if I get some paper. So here is my paper. I know it's a rotation, so I'm going to place that on here. Draw my triangle going from P to Q, so draw triangle P on my grid. Now I'm going to have to hold it somewhere, and at some point it's going to shuffle, and if I spin it around, it should give me Q. There we go. Okay, so the point I did it on here is the point at which these lines crossed. So now we've sussed out everything we need to know. We know it's a rotation, we know it's 180 degrees, and you don't actually really have to specify direction for 180 degrees because it's the same clockwise, anti-clockwise. You can write whatever. Don't have to write either of them for 180. And the centre was this point here, which is the x along the corridor -1 and up the stairs 1. So that's kind of a tricky transformation question, but that's how that one works. Okay, next exam question says rotate A, so the triangle A, 90 degrees clockwise about centre. So first of all, the three things we needed for rotation, this is a good example of it, writing it down here. So we've got the angle here, 90 degrees, we've got the direction, which is clockwise there, and we've got the centre here, and big O means origin. So we're going around this point, 90 degrees clockwise, so this way, the way the clock ticks. Now some people can see this really well, but I'm going to get the paper just to demonstrate. Okay, so here's my sheet of paper, and I'm going to put it over there. I'm going to mark my triangle A there, and then this is my centre. So I need to go 90 degrees around this. So I'm going to go from here to here. It does move a bit, but as we can see it's there. So now I want to, without forgetting where that point is, draw it. So it's 1 below 2 and 1 below 4. So if I remove that here, I'm going there and there. So doop, 1, 2, 3, 1, 2, 3. There we go. So the next question is enlarge triangle B by a scale factor 2, centre 1, 2. So as we can see, just like at the start, we discussed it needs a scale factor and it needs a centre. So it's given us all the information we need, so let's do it. So first thing to do with an enlargement is find the centre. So 1, 2. So this is the x coordinate and the y coordinate. So 1, along 1 and up 2. So this is the point in which we're enlarging by. And the way these work is like this. So scale factor 2, so we're going to multiply everything by 2. So for example, we can see if I do each point again, so each corner. So as we can see, this is 2 away. But it's 2 away, so we need to multiply that by 2, and we need to get it 4 away. So 1, 2, 3, 4. So we're going to start here. Now this line, so now we can see this line here is 2. So instead of it being 2 across, we're going to multiply that by 2, so it should be 4. So 1, 2, 3, 4. We can check this corner here now, so that should be 1, 2, 3, 4 away. We multiply by 2, so it should be 8 away. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Let's do this one more corner. So this one's a bit more tricky. So we've gone 1, 2, 3 up. So that should be instead 6 up. So 1, 2, 3, 4, 5, 6. Then it's gone 2 along. So instead of 2, we multiply that by 2. So we go 4 along. 1, 2, 3, 4. Okay, now we can attach all our corners. And that is our answer. So we've enlarged the triangle by scale factor 2. Now this is why the centre is very important. You can't just blow it up by 2 and plonk it anywhere. You have to blow it up by 2 from this centre here. And if you can see, if we drew these lines from the centre, they should all go through the same corner points like that. So that's a nice check. Okay, so next question. Describe fully the transformation that maps P to Q. So it's a transformation, so we know it's one of these, tree spelled incorrectly. So it's either translation, reflection, rotation, enlargement. So it's not an enlargement because nothing has changed size. It's not really, it doesn't look to be a reflection because I don't really know where you'd put a mirror. Rotation, it hasn't really changed orientation. So we're kind of looking at translation here, so kind of the shuffle. So I'm going to go with that it's a translation. What we need to do for a translation is work out this kind of column vector here. So the way I do this is again looking at the same corners in each shape. So if we go from this corner to this corner, what have we done? We have gone along 1, 2, 3, 4, 5, 6, 7. So I'm going to start with putting 7, and then we have gone down 1, so minus because we've gone down 1. So I'm going to go with that, but I'm just going to check like this point here and see what happens to this point here. So we've gone 1, 2, 3, 4, 5, 6, 7, and 1 down. So that seems correct. Let's just check this corner. So we've gone 1, 2, 3, 4, 5, 6, 7, and 1 down. So that is my translation. That is my shuffle. Okay, this is our next one. P is reflected in line x equals -1 to give shape Q. So let's start with that first. So first we need to identify the line which we're reflecting. That is x is -1. Okay, so now let's reflect this shape. So I'm going to look at this corner and this corner, and then you kind of didn't do the reflections of the opposite. So it's 2 away from the line, so it's 2 away from the line, 2 away from the line, 2 away from the line. Do this one, 1, 2, 3, 4, 1, 2, 3, 4, 5 away from the line, 1, 2, 3, 4, 5. You could also do it by doing it's 3 across from here, so you know it's 3 points that way. That line is 2, that's going to be 2, to give shape Q. So that's how you get shape Q. Okay, next step, Q is reflected in the line y equals 0 to give shape R. So same thing again. What is the line y equals 0? So y is going to equal 0 all along this x-axis here, because any point along here y is 0. So let's reflect again. So we're going to have that point is 1 away, that's 1 away, so is that one. So this one is 1, 2, 3, so 1, 2, 3. So it's going to look like, and that's 2, so that's going to be 2. It's going to look like that to give shape R. Describe fully the single transformation that maps P to R. Okay, so we're going from that one to that one in one step instead of 2. So we have options T, R, R, or E. It's not an enlargement because it's not growing or shrinking. It's not a translation because it's rotated, so it can't just be a shuffle. Reflections we've done, but like that was in 2 steps, so it has to be, so we know it's rotation. But we need to know the angle, the direction, and the centre. So I'm going to get some greaseproof paper again so we can have a go at reflecting it. Okay, so just like the example we did previously, I'm going to start with my centre being the point at which these 2 reflection lines meet. So if I draw shape P about there, and I'm going to start by picking my centres where these meet. So I'm trying to get P to R. So let's see, if I do around here, let's say I go this way, that would be 90 degrees. So it's not that. 180 degrees, hello, that seems correct. So we know our answer now is the angle is 180 degrees. The direction, because 180 is halfway of the circle, so it will be the same anti-clockwise or clockwise. So if I show you that as well. So that way I did anti-clockwise. If I go 180 degrees clockwise, so that's 90. And that is 180. So you get the same answer, 180 degrees, if you go clockwise or anti-clockwise. So you don't actually have to specify for if you have 180 degrees, but you know, good practice. And the centre was this point here, which is -1 along the x-axis and 0 up.